Welcome back. We here at Golioth have been doing a ton of work with OpenThread, and we're pretty excited about the potential that it has and wanted to do a video that kind of shows you what to do after you get through that first tutorial to set it up. So Chris, what are some of the things that you're excited about? And maybe you can just tell us a little about what OpenThread is.
Sure. So OpenThread is an implementation of the Thread networking protocol. So the Thread group is an industry group that came up with this protocol. They publish it. We're actually new members now. We're really excited about that. Baby tiny members. And we got to present there recently. We are very big fans of the networking protocol itself. OpenThread is developed by Google, and that's what we use on our devices. And we're going to show you based on a lot of their tutorials on openthread.io, I believe is the site that we use to kind of get up and started. We also have a video that we recorded previously showing just device management that was between myself and our CTO Veet. We showed using nRF52 dongles, which are little USB dongles, and a centralized border router. So we're going to take this a little bit further today. So basically, we're not just going to show kind of that it works and that it can work and kind of the general background. That other video is good for that. Today, we're going to show you a little bit more of the how it works and really how to handle it when it's not working. I guess that's one of the big things that we've run into, is that there's a lot of new troubleshooting methods and tools, and there's going to be a future video that Mike's going to be heading up here about Wireshark. So keep an eye out for that as well.
And so this is 802.15.4. So if you've heard those numbers like with Wi-Fi before, so it's different than Wi-Fi. What is the RF protocol in this, Chris?
So it is 6LoWPAN is the, I'm not sure, I always get these different things. So the networking protocol is Thread, I know that. And then I think it's the handling layer or something is the 6LoWPAN or something like that. The nice thing is you don't have to worry about it usually. If you're using parts that already have this stuff in there that is using OpenThread, you kind of just don't have to worry about it. And that's about the layer that I'm at. So this is all the stuff that we're building on top of is the nRF52 which is a Nordic Semiconductor part. We're using Zephyr for the modules that we're building. And then we're using basically a command line layer from the code running OpenThread on these devices. It's if it's the Zephyr implementation or the other OpenThread implementation, there's basically a command layer that you talk to these devices over a shell.
Well, let's take a look at that.
Okay, so I think first thing we want to do is look at the documentation site. So we've been setting up this documentation site here. So this has basically some of the getting up, going, system diagram, things like that. Basically, we have some directions on creating the various pieces that you're going to need. And so this is something that I have on my desk right now. So I'm gonna actually switch to that. And so right now what I have is two big things. So this is a Centrius BT510 out of its shell. It looks like this normally. And I've got a little debugging cable plugged in here. This is what we're gonna be running Zephyr on. And this is running as a OpenThread node. I believe it's a full thread device currently, maybe a minimal thread device, but basically there's different classes of hardware. And basically, I think the easy way to think about it is how much battery they're using. And then over here on the left, just turned off, but this is a Raspberry Pi in a case. And if I just flip it down here, what you see here is that it also has this dongle, much like Veet had in our last video. It's an nRF52 dongle, and it's running the RCP firmware. And so basically this is a remote coprocessor, radio coprocessor, thank you. So basically this has a USB interface to the Raspberry Pi, and then it's talking the 802.15.4 like Mike talked about through the nRF52 chip. And so we're basically just doing that. And if you looked at those directions that were online, it was showing the directions are kind of showing you how to get to this point where you have a thread network set up. So we're assuming that you're going through these directions. These directions here are a work in progress, but what we show you is how to make an RCP using a precompiled binary, which we think is a little bit easier than some of the OpenThread.io directions. Then getting that onto the dongle as the RCP, then creating the border router. So actually downloading the required packages onto your Raspberry Pi. So between the RCP and the Raspberry Pi, you now have what is basically a border router. And then finally, the last piece, which is yet to be included here yet, you see there's no thing for it, is making this firmware for the node. But while it's not in the directions yet, there is a standalone Zephyr repository here, and this has directions, which will then be hopefully translated into here soon. So these three pieces are what is necessary to actually stand up your Thread network. And if you look at what that Thread network actually is, again, we talked about this in the video with Veet, but right now, the router, this is my, am I getting this right? I get these terms wrong. Yeah, I think it's wrong. I think it's right. So the leader is the Raspberry Pi border router, and the router is the little node, the BT510 node here. And so this is just the topology menu. What I'm doing right now is I'm on the same Wi-Fi network that this Raspberry Pi is on. So I'm actually SSH'd into into that Raspberry Pi and just looking at the port 80, it's serving up this web page, which is a really nice thing here.
Yeah, and you can actually get a ton of information about the network and kind of see how it's working there. And I think pretty much anyone can get to this point. I think the next question is like, well, what do I do now? And so I think both of us have gone through that with our setup. Maybe you can take us through a little bit of like the guts of like, once I turn everything on, how do I look and see if it's running right? How do I make sure? With me, I couldn't get my nodes to talk to the network at first because I had some trouble there, and we should kind of walk through that.
Yes, I think that's right. So I think the first step then would be logging into your Raspberry Pi. So I am SSH'd into the Raspberry Pi on the right side here. Not sure if it's big enough text, maybe a little bigger.
Yeah, a little bigger.
A little bit bigger. Okay, perfect. So
yeah.
I'm doing split screen here because I want to have, on the left side, this will be the node device. On the right side, this will be the border router. But the first thing I want to do is just see if the service is running, right? So I ran this command recently, but we're going to do it here. So basically sudo systemctl status OTBR-agent. Now, anytime you see OTBR, that is OpenThread Border Router. And so basically this is a system service on Linux, and it's basically a daemon that's just running and sitting there and listening to the little dongle, the RCP that's plugged in, and then you'll be able to see some of the status about what's actually happening here. So let me make my screen a little bit more lopsided here. Ooh. Okay, so what we see here, look at that. That's really something. So what we see here though is that it's handling all of the meshing that happens, right? So one of the key pieces of the OpenThread code is that you need to have something that's not only making those initial RF connections between the two using the 802.15.4, but you also then need to have something that's commanding like, hey, you new device over there, you have these capabilities and you're talking, here are the other nodes in your network, and please forward along messages, or here's a message that has been forwarded along. You need to basically have something correlate all that stuff, and that's what the border router is doing in this case. And then once the node is out there and it has something to send back up the chain, so say you have a node a mesh network of 5 devices instead of just one, you might have something that's 3 devices away. It's sending a message out to the wide internet, but it's doing so by hopping between these mesh devices, finally getting to the border router, and the border router says, oh, I know where this is going. This is going to this part of the internet, maybe the Golioth cloud in that case.
And here we're really not doing anything more than making sure the service is running. So it says active running. We know everything is good here. When I set it up, I set it on a Raspberry Pi 02W, and my OTBR web, which is the web interface that you showed before, wasn't running, and my Taiga wasn't running. And those are both important. Do you want to talk about those a little bit?
Sure. So the Taiga first is the thing that's doing. So one thing that we talked about in the last video with Veet is you need to have something that is helping your IPv6 devices, which is what Thread devices are, all IPv6 because of the wider address space. And actually, I'm not sure why else, but I think there's stuff online about why they're IPv6. But you need to then translate that to IPv4, and you need to actually have something that is sitting in between the IPv4 of the wider internet, most specifically my home network, which is only IPv4, and the Raspberry Pi here. So Taiga helps to do that lookup, I think, at the NAT layer. Anything networking I am completely hopeless with, but what Mike and I know is you need to have Taiga running. So Tayga. And so I'm trying to find the command here.
It's the same one, just with Taiga instead of OTBR agent.
Okay. All right. So Q to get out of the current thing here. So we'll just go Taiga.
And that's
again,
running, which is excellent. That has a configuration file. I think it's under etc/taiga.conf. Those will be in the instructions for anyone, but mostly you want to look and say, is this running? Sometimes it's not enabled.
That's right. Yeah, and if you do need to enable or disable, right, that's one thing that you can do here. You can do sudo system ctl enable Taiga. I'm just going to say you're already enabled. Basically, this is, you know, like any other Linux-based service. You can start, you can stop, you can restart, or I guess enable, disable, and restart are common ones there. All right. Now, another thing that's really critical here that I think Veet showed in the last demo is the IPv6 NAT64 route. And this is another critical thing here, right? So this is, so the command here, which we will have in our docs as well, especially in the troubleshooting section, this is adding a route to, and I think this is actually because it's OTCTL, I think this is actually adding it to the RCP itself. But this is important here because you need to actually tell it the translation layer to the NAT64, I think. I'm probably saying all these things wrong, but once you've done that, then you also need to register this. So we're basically doing magical incantations to make this stuff work. We'll have some troubleshooting guides in there, but at the end of the day, what we should be able to do, and this is really the long thing that we took to get to, is you want to be able to, not from here.
Yeah, you should be able to ping it from there.
From here, yeah.
Yep.
So this is basically pinging the Google DNS servers. 8.8.8 in IPv6 land is this whole mess here. So this is basically showing that from here, we can actually ping the Google servers, which means we are getting through to the wider internet through IPv6 with an IPv6 address, and it's able to back calculate all that stuff.
But at this point,
what am I missing here, Mike?
Well, we're still completely on the Raspberry Pi, which is the border router. Right. So we haven't actually gone out and looked at one of the nodes in the mesh network yet. So maybe we should pop over and do that.
Sure, let's do that here. I'll just draw this over here. So I guess I should have just had a different tab here. I'm like, so I am connected to, I actually have a node that's already connected. This is where I was building the code, but I can also look at the serial connection because with the BT510 and that special debugger that I showed you, it actually has a serial connection through the tag connect, which is also pretty nice. So what I'm going to do is picocom, and then I'm going to do ACM0 because that's the one that's showing here. So this is our friend here. All right, and so what we see here is that we're dropped into a shell. So we're actually on the Zephyr device now. So just to show it one more time here. So we are currently talking through this device here, and normally it's in this sort of case, but it's talking. So there's an NRF52840 in this RF safe module here. We're talking to it through a tag connect connector, and then it's talking to this programmer board from Layered. Layered is the people who make this. All right, so now we're back to
just for the shell that we're seeing here, though, but it's actually going through Bluetooth to the border router as well.
That's right. Yeah. So the shell that we're seeing is through that serial terminal. Everything else that we're seeing, all the connections to the actual internet, is through its Bluetooth, like you're saying, or through the 2.4 gigahertz radio. All right. So now we can start to check some of the commands for, is this thing connected? And so actually there's an indicator LED, which you see the green LED here. I know that because that's turned green, like on the dongles that we also showed in the last video, when those are turned green, it means that it actually is connected. But we can check that here. This is the state command. A little help, OT state, is that right?
That's right.
OT state. All right, so this actually matches what we saw here is that it's this device here is the router. So that is the light blue one. The leader is the Raspberry Pi, or the OTBR, OpenThread Border Router. And that's actually, so basically this router is sending packets through over 2.4 gigahertz to the OpenThread Border Router, which has that RCP dongle, and then it's forwarding them along to the broader internet. So I think we can do the same thing that we did on the last one, on the other window here. Let's see if I can, what is the address? So I should be able to just ping Google like we did otherwise.
And in this window, we have a special shell for OpenThread turned on. So all these commands, you start them with OT, and then the thread command to run them on that shell.
So I'm going to try and ping the same Google servers from the node, the thread node, going through the border router out to the broader internet.
Yay!
Yeah.
Successful demo.
That's right. We're done. And so what this is showing is, yes, we are able to ping a wider internet address from this tiny little 2.4 gigahertz node running Zephyr. Now, what you saw happen in the meantime here is actually the code that I have running on here. These are some debug messages, but these are actually, this thing is actually every 300 seconds, every 5 minutes. This is actually waking up, taking a reading, sending actually a bogus data right now, but basically sending a reading over LightDB stream, which is a Golioth servers, and then hitting the Golioth servers as well. So that's another way that you could go and check to see if you have things working, right? So I'll show the Golioth console right now. This is similar to the demos that we've had before. You should see OpenThread BT510-2. This one is online. And what we can do is if we hit LightDB stream, we should also see that it just sent a message. 4. And so that's the fake reading it's sending through right now. It's just sending basically a test element. But we can also see if we go to logs. If we go to logs here, I go to the last 4 hours. We also see, that's a little too big. There we go. And so this is the same logs like the LightDB stream message, and then also logging messages, which are some of the services that we offer.
Now,
what happens if it's not working though? Because like,
yeah,
this is
that's
all
what I was just gonna say. Yeah,
everything for us, yeah,
great on YouTube, but what happens when it's actually on your bench, Chris?
Right. Yes, that is a great question. So, let's break it. Right. I think that's probably the next best thing to do. So the first thing we want to do is do OT ifconfig down. And what that's going to do is basically now if I do OT state, we should see it's disabled. And if we actually look at the little LED now, we also see that it's no longer green. It's orange. So at least on this device, on the dongle, I believe it just turns off. On the NRF52840 board, it just turns off as well. But this is a multicolor LED. So there we go. So now we also see that it woke up. It was trying to reach the Golioth servers. Oh, you can't see that. Thank you, Mike. It woke up. It was trying to reach the Golioth servers, and it says, "Yeah, I can't get to it." So that's because we've actually done this. So one thing you're going to often have to do in your troubleshooting is making sure you're connected to the right device network. So let's go through that first. So we've taken this whole thing down. What we want to do is we actually want to let's actually go and restart a whole new network now. Oh, this is dangerous. Actually, we can go and look at the topology real quick. We should only see a single node on here right now.
We really did break it, Chris.
Yeah, I did well. So we see the leader. This is the OpenThread Border Router. It's just sitting there. 1 is the loneliest number. All right, so let's go and form a new thread network. Right, we actually already have one formed, but what I'm going to do is go and form a brand new one. So we see that we're going to keep the default name. This is basically like your SSID, what's the like a Wi-Fi name and password. That's kind of the same thing here. So network name is like your Wi-Fi name. Password is like your network key here. So I'm going to go say form a new thread network. All right, form operation is successful. If you're booting the first time, that's also something you're going to have to probably do here. Again, we're going to see just a single leader here, but we actually, well, we didn't see it before, but this is actually a different address than it was before. I think it was 0x7200 before. Now it's 0x800. And so now I'm going to bring my device back up. So now again, we're back into the shell on this device here right now. And actually it just turned red. So that might actually be because it lost knowledge of that other device as well. So let's go, and what we want to do is first tell it, hey, what network are we going to be on here? So we're going to say OT dataset network name, OpenThread demo. Then we're going to give it that very long, moderately secure password. And then finally, we have to actually go and commit this to the localized memory. Again, because we're in the shell of the Zephyr device and it's running the OpenThread firmware, we're going to do that. It's already down, but we'll just for good measure, we're going to do, this is kind of the loop that I'm used to doing. We're going to do OT ifconfig up. So now we're bringing that network connection back online. We're saying, yeah, you're good to come online. And then finally, we're going to say OT thread start. And now we hope for the best. No color changes yet, so we'll see how this does. So now we're going to go to OT state. Oh, all right. So it is listed as a child, which is good. Now, if we go back to the, yeah, go ahead.
The other one that I like to run, Chris, is OT net data show.
OT net data.
It looks like you just turned green, so you're good there. Space before show. And so this actually shows us like the routes that we set up. And so if you don't have any routes in there, you won't be able to get your IPv6 Taiga call, and you won't connect to Golioth on that. So this is a pretty handy command to have as well.
Yeah. And so another thing that's useful that I found, just I don't know the formatting here, but just you notice that 0x00, you can start to see like, oh, you start to correlate these things because it's talking to the Thread Border Router, and it is that network name here. So I would venture a guess that this node that we have the photo of on screen, I would venture a guess that it's 0x01 because it's usually assigning sequential numbers there. But it is talking to 0x00, which is serving up these other services, in this case, these service processes and stuff like that, and IPv6 addresses. So
Chris, I think you keep saying 0x instead of 08, but you mean 0x00. Yeah.
Thank you. 0x0800. That's right. Yes. So, and then 0x0801. Let's go see if I'm correct. So again, we're back on the Raspberry Pi. We're looking at this thing here. Look at topology. I expect 2 devices. Yeah. And actually it has been promoted from a child to a router. I was definitely wrong about the device name. So it's 0x5000. I thought it was going to be sequential, but that's okay. And yeah, and so now when we go back into this device, I would expect once again, we're able to ping. We're not able to ping. Let's go copy that message here. And once again, we are able to ping the Google DNS servers, which means that we are once again connected through the board from the node device through the border router out to the wider internet, and we're able to see devices or see things out there. Whew, that was quite a journey, Mike. I'm surprised that we got it all in one go. Not I think a brief thing, but
yeah, well, I think that's a good demo. I mean, a lot of this stuff when you're standing up your first network, it's like I said, you get through the first tutorial and you're like, okay, well, now what do I do with it? So I think just getting used to these commands and playing around with bringing nodes up and taking them back down. You know, obviously, if you're standing up a huge network, you're not going to be typing in the dataset commands for each node, but you need to know how to do this in order to troubleshoot it and to make sure that your first network is actually running.
That's right. Yep. What we've shown here is that we were running a BT510, a layered node running custom Zephyr code. And the reason we're doing that is because you can then implement Golioth functions. We highly recommend you try that out. That's part of the tutorial site that you saw and the GitHub repository. So basically you do that and you can go and start to manage an entire fleet of networked Thread devices. And we think that's pretty cool, right? These are low power devices. They're mesh networking. They pass data back to the network. The reason we can do all this is because we run API endpoints that are based on CoAP, which is the transport protocol, which is what the Thread network uses. And because of that, you can do things like passing back time series data, you can do command and control, you can do firmware updates, and you can do logging. Those are the 4 things that we're really good at Golioth, and we would love for you to try it. So please go check this out, try it yourself, let us know how it is, and we'll see you on our Discord forum or our regular forum.